Hello, everyone. Welcome back to another lecture on intelligent systems. This time, we are talking about text mining. More precisely, we'll talk about natural language processing, the foundations, various NLP steps, and how you implement them. And then we look at text mining as an example application of natural language processing. There are, of course, lots of other applications, but in the context of intelligent systems, we're looking at text mining as one application, and another one that is sort of ongoing is the application in the context of a chatbot. So that's the plan. I'll give you a quick introduction to text mining. We look at NLP, various processing steps in NLP, how you implement them, and then come back to how to use it in a text mining system. So what's the motivation? Well, the main problem everybody is facing is information overload. Yeah, you have all of these information available online nowadays, books, documents, web pages. You get all the text messages, emails, blogs, news. You have research information, business information, memos, everything electronically, and you can access it instantly. We have databases, information retrieval, like search engines, and you can immediately retrieve them, but that doesn't mean that they are immediately useful for you. So if you type a term like text mining into Google, it will take less than half a second for Google to tell you that there are hundreds of millions of results. So now how many seconds is it going to take you to go through 700 million of these results? Well, you're not going to manage it for this term in your lifetime. Maybe you look at a few of them, but then you don't know what you missed in all of the other documents. So this is what leads to the perception of information overload. And I also found the somewhat less used but entertaining term of information rage. Now you have so much information that you're just getting frustrated. And we also know from various studies that paradoxically, when humans have more information available, they often make worse decisions than when they have less information available. So we have databases, information retrieval. This scaled very well. Systems like Google and other search engines, they now index the whole web, but humans haven't really improved. All of this information is accessible, but not really available. So this old approach of a poor worker, again, this technical term of knowledge worker, who is directly accessing the documents, quickly comes to limits. As an example from science, there are lots of scientific publications in medicine that, for example, look at cancer, how tumors develop, how you can treat them. And these publications are full of information like the one shown here. The deletion mutation on exon 19 of EGFR gene was present in 16 patients, while the L0858E point mutation on exon 21 was noted in 10. All patients were treated with getfitinib and showed a partial response. So just from this small segment of one publication, you can conclude that getfitinib can treat tumors with EGFR L858E mutation. Mutation, you've probably heard. Nowadays, they are everywhere in the news because of COVID, but obviously they've played a big role, not only in medicine, but also industrial applications. So at this point, you might think, okay, what's the big deal? If this is your specialty, if you specialize in developing drugs for cancer treatment, then you just stay up to date with this very limited subset of the literature. But it's not that easy. There is a portal, PubMed, which curates all of the documents in biomedical research. So you can access all of them through this portal, which is very nice. We don't have that in computer science, for example. It's all over the place, but everything biomedical you can find in PubMed. If you've never seen it, have a look at the website. It's interesting. So this number here is a bit more than a year old. There's probably a lot more because in addition to the millions of abstracts that are already in there, it adds roughly 2 new abstracts every minute, meaning more than 1 million every year. So nowadays, it is impossible for a human to stay up to date, even for a scientist, for a researcher in a very limited subset of the literature. Yeah? You can maybe read a dozen publications a week, and even that means that you don't have time for much else. But with 2 new abstracts every minute, even if only a subset is in your specific field, you will never get up to date. You're going to be behind. You're going to be years behind in research, and you will never be able to catch up. So that's a big, ugly truth nowadays. We publish all of this research, but the people that need it, the scientists, the researchers, they simply can't keep up to date, which leads to all kinds of problems. Now, you don't have the information that you could use right now. Maybe you're duplicating research because you're not aware that something has already been done, and so on. So the solution is we don't just use machines for storing, indexing, and retrieving. We also use AI techniques for reading these documents and creating something structured out of it. And what that could be, you've already learned. Now you build something like a knowledge base. So each abstract in PubMed has an ID. So these are very old ones because it's a small ID number. So in document 1, 2, 3, you have some information. In document 4, 5, 6, you have some information. And the goal is to create a knowledge graph, like you have done manually, but now do it automatically. So have a program read these publications and as one application, build a knowledge base, which then can be used by other scientists to make, for example, queries against this knowledge base. Another example I showed you in the very first lecture, which is the analysis of news. This is the European Media Monitor, which was originally developed for politicians that want to know for all the news across the European Union, what is happening, what news are trending for specific topics in specific countries and specific domains and so on. And also look inside those articles and find out what is being said. So originally, again, this was for politicians. They want to know what is being said about them and also what they are being quoted with in the news. And rather have some poor people go every day through thousands of publications, read all the articles and try to extract this. They build this system that reads news and automatically extracts, collects, and combines these quotes. An example here, you see all the quotes from. So everywhere in a news article where he was being quoted as saying something, this is now collected and cross-referenced with the news article where this appeared. And if you look at this, there's also the opposite version, quotes about. So you can see everything that was said by other people about this person. And I also mentioned that there's a related system, the Medisys, which does sort of the same thing. It analyzes news, but here it focuses on medical topics. So medical events, diseases, and so on. So the first step now is to use AI, specifically use natural language processing, so that the poor human doesn't have to read through these hundreds or thousands of millions of articles, but the computer does. And then the human can interact with the results produced by this NLP pipeline. And just to get a feel for it, the there is a small task to try out this EMM system by yourself. And then I'll see you back in the next lecture part.